everyone. We'll be starting in a few more minutes, so do grab a seat and make yourself comfortable. Thank you.
So you have latency in the system?
Right, good afternoon, everyone. My name is Tuan from SGInnovate, and thank you very much for joining us here today as we discuss the future quantum economy. This is part of our long-term partnership between SGInnovate and the Centre for Quantum Technologies at NUS. We want to work together to build up and raise the quantum awareness and readiness in our future economy, as well as to help commercialize some of this research work that among our local research community. So to get us started, I would like to invite our partners, Arthur, who is founding director at the Centre for Quantum Technologies, to share his thoughts on the spirit of our partnership. Arthur, please.
Oh, thank you very much. Thank you. So I just want to say that I'm very excited to see this fusion of research and commercial world coming together so nicely. When I started as a director of the Center for Quantum Technologies, it was about over 10 years ago, I never expected at the time that we reached the level that we will be talking to our colleagues from SGI who would be willing to talk to us actually and learn something and see how what we are working on in our labs can be taken further to the commercial world. So that came as a big surprise, I have to say. So, you know, that our collaboration is, you know, has already manifested itself in few events, and we were very surprised to see how much interest is there in quantum technologies and quantum computation, quantum information processing in general. So I'm very grateful to our colleagues from SGInnovate to not only to embrace, be courageous enough and look into quantum very seriously. We scientists usually don't think about commercial applications, and so it's great to have such a great partner who can actually take this role. And it's nice to actually have someone where we can combine forces, so that everyone does the job that can do the best. So we know and we think we understand a little bit about quantum, and SGInnovate knows about how to take this into something that has a commercial value. So I have to say that I also would like to thank SGInnovate to invest in some of the startups that started from CQT, at least 3 of them. And that shows that people truly believe that, well, at least on your side, Steve, I think, that you truly believe that something good will come out of that. And I'm also quite inspired by some of my colleagues who ventured from academia to this commercial world, and like Joe Fitzsimon is a good example where he believes so much in the quantum future that he sort of decided to, take sort of like a break from his academic career for a while and focus on developing some ideas in the quantum world. So the fact that Singapore, such a small nation, can make a difference in this field is another fantastic thing. So we are a rather small island here, but in this particular field, I think we can make a real difference. And I think that having this partnership will make not only the research much stronger, but gives it sort of a better context. We together, I think, can form a quantum ecosystem in Singapore, where you not only have researchers, but you also have other entities. You have defense, you have people from the commercial sector looking into this. And as such, Singapore will be probably well placed to be very competitive in years to come. And I'm pretty sure that the quantum technology is the technology of the future. So thank you very much.
Thanks, Arthur. And Arthur was saying that he's just flown in from New York, so I appreciate very much the opportunity for him to be personally involved. Briefly, from an SGInnovate perspective, Arthur covered a few key points. One is we do want, and the reason that we set this place up was to be a teammate to entrepreneurial scientists. And so the whole idea is we don't add value to the science, but we do know how to help build companies. And so from that perspective, our goal was Singapore is doing great work, great research, has the foundation of education, has the long-term, predictable, consistent commitment to scientific research, but we weren't doing, at least in our opinion, doing as much as we could with it. And so that's why we set up SGInnovate just about 3 years ago. And so the thing that I'd like to highlight is we don't know, very transparently, we don't know what this basket, and I'm going to make it a very general statement of quantum-related technologies, because it's not my goal to try and talk about hardware or other, but instead this basket that I would refer to as quantum technologies. We don't know where it may go, but we are also curious and want to be a part of helping express that. But what we don't do is we don't invest so much in the technology, we invest in the people. So we invested in Joe. We didn't invest in Horizon, right? Horizon becomes the vehicle, but we invest in Joe, and we want to invest in others, Chunyang and so on, right? We invest in people. So I think the most important thing is at this moment in time, with a deep tech startup, more than anything else, because of the immaturity of the technology or the company, really 98% of what we do is say, is this an outstanding or amazing person with whom we think we can do something to be helpful to them and ideally build something that people care about and want to be commercially successful. So to clarify, compared to other investors who invest in a company and can look at cash flow and think about traction, for us, it's all about people. And so one of the requests that I will make of this group, and the reason we have these events, is to get to know more people that are interested in this journey. So the reason that we love the CQT relationship is the opportunity to work with amazing people. But we always need this group effort. So anybody that would like to be an advisor, a mentor, a coach, a teammate, whatever the right avenue for you, please help us know you, because that's how we grow. So we have today about 28,000 people in our database, which we've built through these events. But what we always want to do is know when to reach out to you. So if there's something about quantum technologies and you think that there's something from a business perspective or a technical perspective, please help us know you so that we can reach out to you as appropriate, right? So these things are built by people. They're not built by entities or organizations. So we treasure the working relationship with CQT because we would like to be a teammate to help prove what we believe, which is that quantum technologies will be important, increasingly important, and that Singapore has a role to play. So we appreciate very much the opportunity to work together with CQT. So now we're going to sign an MOU, or MOI, I guess it is, to memorialize the sharing of talent, creating events to be together, creating platforms for people to invest and work together, and ideally to build companies that make a difference and continue to show that Singapore can punch above its weight. So with that in mind, I think now, Arthur, it's up to you and me to sign this MOI, and then after that, just to set your expectations for those that have been here, you know that I'm going to call upon you to stand up and smile. So we're going to sign this first. We're going to do a couple of formal pictures to memorialize the event. Then what we're going to do is ask you to be a part of it, and we're going to stand here and take a picture this way, in which I'll ask for my teammates who are going to be on the panel here with me shortly to join. Number two, please be thinking about the questions that are on your mind. I've thought deeply about the questions that I'd like to ask such a panel, but it's important that these become interactive, so it's going to be as important and interactive as you make it, because I don't want to try and come up with 37 things to ask. I have some areas that I'd love to learn more about, but it's important to see what you want to engage on. So please, through Slido or good old-fashioned raising your hand, be engaged with the panel when we get started. Okay, so with that in mind, Arthur, it's up to you and me. So we're going to sign this MOI together. I'm sure it's going to be amazing and spectacular, so don't blink or you're going to miss it. Here we go. Wow, we even get some cool music. And we smile. Okay, that was the MOI signed between Center for Quantum Technologies and SGInnovate. Thank you very much. Okay, and now, Arthur and Ranyao and Chunyang, please join me in, we're going to stand roughly here. Joe, come on, stand up. Dimitri, stand up. Everybody please jump up, because what we're going to do is sort of have like the we were all here. And by the way, this is an important opportunity for us to prove to all the non-believers that we can get more than 7 people to talk about quantum technology. So, you want to give us a 1, 2, 3, 4?
All right. Everyone is in the frame. Very good. Okay, 1, 2, and 3. Feel free to wave your hand here as well. 1, 2, and 3. Perfect. Thank you.
Okay. Thank you. There you go. It was that easy. Okay. Arthur and Ranyao and Chunyang, can I ask you to join me, please, wherever you would like to sit? Thank you. Okay, I've got Slido with me, if that's your preferred way of asking questions, so I'll be keeping an eye on it from time to time as we go through. And we can jump in. Is everybody, hey, nope, almost under your picture, but that's fine. Here's what we're going to do. We're going to talk about what does it take to build a company in this particular space. And again, just to reinforce, it's not my goal for all the experts in the room. I'll ask your forgiveness in advance if I refer generically to quantum technologies to avoid trying to be too specific about any one use case. But what I'd love to do is I want to jump in basically and ask Arthur for you to perhaps share a little bit. You were the founding director for CQT. Help me understand a little bit about the journey that the organization has been on in terms of the type of work, the talent, just the observation about how awareness has been increasing. You and I were chatting a moment ago. You referred to it as becoming sort of a sexy topic, but perhaps also some misunderstandings or perhaps hype. Just let's get started by sharing a little bit about your thoughts.
Right. Well, Steve and I were talking prior to this event about difficulty of, one hand, explaining what quantum is to public at large, but at the same time about the kind of a mysterious magnet it has, right? So kids and people like the idea of a mystery, that there's something very unusual going on in this world of atoms and photons. So when we started research in Singapore about 10 years ago, actually earlier than that, over 10 years ago, in the Center for Quantum Technology, so it was quite clear to me that it has to probably have three components. First of all, CQT has to have really first-class research. So we have to really understand what those atoms and photons are doing and how they behave and how to control them. But that's not good enough to succeed in Singapore, in the local context, but in general. So then you're burning taxpayers' money, right? So you have to somehow, at some point, tell people what are you doing in this lab. And it's so different from, say cancer research. Everyone can relate to cancer, and people understand why is it important. But to explain why quantum is important for such a small nation, it's not trivial, right? So it was quite clear to me that we have to stress on outreach. So we have to really have a team to tell people, those who are interested in the field, but also people who from a commercial sector who might be interested in learning more about it. And the third aspect was, and this is basically to some extent what this event is about, is to connect with commercial world, to make sure that at some point, Singapore being Singapore, the basic research is fine, but sooner or later someone will come and ask, what is it good for? Why are we spending all this money? Is it something just for intellectual curiosity only? And so to me it was quite clear that even though we were given license to do basic research, it was always sort of in the background that it will be even better if you could succeed reaching to industry, to the commercial world, and see those technologies being taken further. So gradually, I think at CQT we managed to achieve that. And so first of all, I believe we do have a very good first-class research in all aspects of quantum technology. To those of you who haven't visited CQT, you're most welcome to pop in at some point and see the labs and see what we can do. And the second thing, I think we have a fantastic outreach team that is organizing all kinds of events. You can visit our website and you can learn about it. But the third thing is coming along over the last 2 years or so, mostly thanks to Chung Yang, who was working very hard to make sure that we have good contacts with the industry. We started trying to sort of create awareness of this new technology among the corporate world. But at the same time, the field took off so rapidly, and as you pointed out, Steve, that even sometimes, to the extent that makes us scientists sometimes a little bit uncomfortable when we talk to media, because we are usually more reserved, more conservative in our predictions. We don't want to just go hoo-ha and say, tomorrow there will be a beautiful quantum thing, that will change your life. That's not the case, but at the same time, we don't want to stop all those people who are enthusiastic and they see all this kind of business opportunity to do it. The difference is, that scientists usually work with things, but doing business has a social context. So the difference is, in business, it's not only what you think that this atom can do for you, but what other people think that these atoms can do for you. So we don't think about it this way. So it's actually very refreshing to talk to those who are in the corporate world. So they have a slightly different perspective, and we are learning. So anyway, so I don't know whether I answered your question. I gave you some perspective.
You've given me a lot of things to connect to, but I'm going to keep going and circle back throughout. There's some things I'd like to build on. But Renyao, let me come to you for a moment. Arthur talked a bit about corporate and relationship and applications, use cases. You work for a very large technology company. Perhaps I should have started by giving each person a moment to self-introduce, but perhaps share a little bit about what your work relates to and the role of the corporation, in this case Baidu, but perhaps also other corporations and the role that they might play different from a research-oriented institution.
So, thanks, Steve. Actually, first of all, I'm very happy to be here for, to accept the CQT invitation to join this panel discussion, because CQT is definitely a world leader in this quantum technologies, I think. So, anyway, let's come to your question. Before I returned Beijing to join the company Baidu, I was a professor at the University of Sydney Technology in Australia for almost 10 years. So last year I decided to go back to join the company because I think there are new opportunities available for this field. So I think for this for company like a big company, I think my personal opinion is that this kind of company, they should be aware of this new technologies, and they should be prepared for the possibilities. Because if this quantum computing actually becomes really like everyone use it, then for this kind of company, they have to be prepared well in advance of that. So this, I think, is the first very important observation I have. And the second one is, I think, this new quantum computing also brings some new potential quantum business. We are not very clear about what it might be. But we know there are possibilities. So we have to think about this kind of new possibilities to discover this new kind of business, and then eventually can, to evolve that, to make the company, maybe another level. So I think that is some basic observations I have. Yeah.
Let me come back and also build on some of those. But Chunyang, before we go further, you represent a person that was working on helping commercialize and bring to the outside world, and you decided to walk that journey yourself as the co-founder of a team working on quantum key distribution. Can you start helping us understand a bit about, number one, that transition, and number two, did you decide that QKD was the most important way that you could kind of express the near-term opportunities for quantum technology?
Right, sure. So kind of to Steve's point, about 3 years ago, I rejoined CQT. In my early career, I was a researcher there. So kind of deep down in my heart, I still think of myself as a scientist at heart. but kind of, through the decade of experience in industry, kind of putting on that business hat and looking at the portfolio within CQT, the research they have, the IPs, and kind of maybe a bit of commercialization strategy vis-a-vis the whole quantum landscape in the last 3 years or so. Literally 3 years ago, it was kind of that breaking out from the lab of certain technologies. There's some cracking in the midst, like in the US, in Europe, in China. In Singapore, I was pretty kind of keen to, because I saw in CQT a lot of value that is built up over the years, not only in the past 10 years, but building on scientists that's gone way before CQT was set up. Right, there's a lot of value there in terms of technology, in terms of the expertise, in terms of talent, and kind of putting on the lens of kind of commercial viability of where we can play globally, where we can hopefully punch above our weight in the global landscape, and kind of identify essentially QKD as one of the core technologies that we have already with good heritage already in space. And so, and that's where kind of that triggered my jumping into the startup to co-found with a couple of colleagues here, and really building on what they've built over the last decade or so, kind of the core technology and demonstrations they've done, and hopefully we'll see where that takes us.
So one of the things that we always face when we are investing in a company, and back to the point I mentioned at the beginning, is people and talent. But especially any startup faces the right talent question. Then you take a deep tech startup, which faces that question even more. And we are at the beginning of our own journey as SGInnovate, but the question that we will be working on together is how do we address the talent question to build commercially successful companies? And I think it's an important point. Our goal is not to launch companies. Our goal is to help build commercially successful companies. It's easy to launch companies. We could launch 10 companies by this afternoon. It's very difficult to build commercially successful companies. And this question of use cases. So already some of the questions on Slido. How do we think about use cases, and what would companies be willing to buy? So what I'd like to do is, I guess just for simplicity, Arthur, I'll come back to you for the moment. When we think about where we are in this journey, are we still heavily, largely in research, just dipping our toe into the use case pond, or do you feel like now we're actually much closer to use cases that can be thought of by companies?
Well, it depends very much. I think there are some parts of quantum technologies, like quantum key distribution, for example, that are closer to real live implementation, something that can have a real impact on data security. In some other cases, like say quantum computing per se, that may be what you said, just dipping our toes into this pool of something that can be useful in the future. But one never knows how fast these things will move. Just you asked me this question about, say, a few years ago, then I would say even quantum crypto, I would say, well, just it's a blue sky research. And it isn't anymore. So in fact, we scientists actually, we are very poor at judging the progress, especially on the theory side. I have such enormous respect for our experimental colleagues. They are much more optimistic about the progress than I am quite often. So even though it is the case that I think in most cases we are just still probing the waters, just very gently here and there, I think it's not clear how fast it may evolve. So it may be that that this will actually move much faster than we all anticipate. So I think that in many areas it's very important to be prepared for this.
The challenge that we face in terms of building companies is investment. right? Because you can have great talent, but you need investment in order to be able to fuel the company. And investors, as a general statement, it's obvious, but it's logical, want to maximize return at the lowest risk in the shortest possible time. And quantum technologies doesn't fit that bill very easily compared to many other options. So we're straddling at the moment this intersection of a bit research, a bit commercial applicability, and that is part of the concern about investment. And so part of what we're hoping to do through these events together with CQT is raise the awareness, lower the mystery factor as best we can, encourage investment. So when we think about applicability, maybe QKD is one of those that begins to help people understand and approach this. When you think about selling your product, how do you sell a product that very few people understand how to approach? AI is already a discussion topic, explainable AI. Do we have explainable quantum technology?
Yeah, I think it's definitely understandable. You know, at the heart of it, you can go into the, you know, to launch a quantum satellite, for example. You can go into the weeds of, you know, what crystals you need to use, what stabilization, you know, thermal stability, and so on and so forth. But as a concept, as a user, you just need to know the key value which the product or device will bring to your organization, and how the customers or the different market segments value that particular product or application is up to them to decide, right? If I'm a government or defense organization, the value of a secure quantum encrypted channel is of, you know, this much value to me, right? And I can ascribe a value to it. Whereas to a medium company or small medium enterprise, having quantum encrypted, you know, communication channel doesn't really make sense at the moment. Maybe if the price comes down in the next 10, 20 years, you know, why not if it's comparable in terms of pricing? But, you know, to that point, I think the research is still ongoing. There'll be several iterations or generations of technology as we go. But at the same time, we can already build out business cases for the different market segments that will bring in, you know, early revenues and kind of to prove the business case over time and so on. So really, I think the key thing is the value ascribed to a particular product, let's say quantum, is up to the customer to decide and not up. I mean, we show them what it is about, but it's up to them to ascribe the value to it.
So, Ranyao, one of the reasons, and I've said this so there's no mystery on this, I'm very amazed by the deployment of AI in China, right? And organizations like SenseTime and so on in terms of use cases. So Li Kai-fu has very clearly said that it's not about research at this moment in AI, it's about use cases. When we take a look at quantum technologies, how do we think about moving from research into use cases? Or should we in fact think that for the next, let's say, 5 years, it's really, honestly, mainly about research, and we won't see deployment, right? Help us understand a little bit about what you see in terms of today iterating on AI is moving it along rapidly. Is there a similar curve that might be possible for quantum technology, which is deploy, iterate, learn, improve, deploy, or do we have to more or less perfect it in the lab and then work on it in the real world?
Actually, I think many people ask this kind of question, and also you, right? I mean, and the typical question I received is about what's the immediate use of this quantum computing, or this kind of question, because this maybe the investors are most concerned about this, right? But for me, I think is maybe the most direct uses of quantum computing is you need to educate, you know, we need to educate our brain to accept the, you know, very fundamental concept of this, because this is very, very difficult. Although it seems a little bit naive, but think about, you know, how many years we spent trying to understand some classical physics. But even now, I mean, most middle school students already know classical mechanics very well. But for quantum, if you catch someone on the street randomly, ask about quantum mechanics, nobody knows. I mean, so if we need to have the confidence in this field, the first thing we need to do is, under the most urgent thing we need to do is we actually to provide this kind of education service to make people actually access this and to understand what these people are doing. I mean, why they're doing this, they understand, and then we have their support, right? And this, I think this represents a huge possible investment area, education. You can imagine, everyone needs this, everyone, I mean. So that's the first thing, I think. But the second thing is about even regarding some immediate application, I think when people talk about quantum computing, we normally care about how to build some quantum devices, right, and how to make this some faster information processing. But actually, the idea of this quantum actually also used to do some classical problems. So indeed, I mean, I hear some many physicists, when they talk about quantum computing, what they actually mean is use some like the large computers to solve, the quantum problems. So I think this already some also very, very useful thing, right? So I think that is a huge possibility. Even now you see people use AI technologies to solve quantum problem, and this also, become very hot topic and attract a lot of, attention. I think that is also already very useful thing. But about the user case, I think that is really, for the moment, to my mind, I don't really know so many useful cases, but I guess one possibility is that how we can actually provide some devices that can actually to help people to understand this, the fundamental law or maybe some fundamental application of quantum computing. So maybe very small scale, but if you can produce some very stable devices together with some very basic, demonstrations, I think this kind of is very useful, like a QKD, right? I mean, I know that people already have this kind of devices, and some company, if they are doing some very sensitive, about security, then maybe they will buy this. This I think there's some possibilities also for, other like education or maybe also for some special use. So that's currently what we can see. But I think that maybe one moment is we should be patient, about this field, because I think it's not really the time to, actually to get the results. It's actually still in maybe 5 years, we need to wait for this kind of time. So this is why our investors have to be also patient, like us, right? Research will do many, many years, so we should be, we also need to educate our investors to be patient. That's also very important.
Okay. We'll try. We'll try to be patient. When I think about, and Arthur, I want to come back to you, and then I'm going to ask questions. I've got some through Slido, but I also love just if somebody wants to shout a question. There's sort of a famous way of looking at this quantum question, quantum supremacy, quantum advantage, but there's not an obvious scenario in which quantum is better across the board. There's use cases in which a quantum compute architecture may be different or have advantage. But do you see that this idea of quantum advantage will remain niche, as in sort of specifically defined use cases, or do you see a future in which what we're talking about as quantum technology will essentially become the standard? How do you look at the future?
Well, I personally think that in long term, the quantum will be ubiquitous, in a sense that there's just no any other way to go. You have to, if you want to improve whatever, if you want to improve computer technology, if you want to improve many things, you have to go to smaller and smaller dimensions, and at some point you reach the level of atoms and molecules, and you have to understand this world. And I cannot see any other way of going if you want to cram more data into physical objects, right? So eventually, I would say people will think in a quantum way. But the thing is, what does it mean eventually? Will it be in 20 years from now? Will it be 30, 100 years from now? That I really, honestly, I don't know. But but this sort of like dichotomy between classical and quantum is a little bit artificial, because in a way everything is quantum for physicists, and classical is you know, some kind of extrapolation of quantum. So that's why I can safely say that everything will be quantum eventually. But the thing is that even today, what is interesting is you see the impact of, if you want to use this dichotomy, quantum classical, so even if you just forget for a moment about the quantum advantage, which I think there is, but you see how this quantum has impact on classical. So for example, there is a reason why we have to think about a new generation of public key crypto systems, because there is this quantum computer on the horizon. So there's a reason National Security Agency says, okay, well, you know, public key crypto systems as we know them today are not secure, so you have to come up with different mathematical problems. Be prepared, you know, it will take some time before we can implement this new infrastructure that will be immune to quantum attacks from quantum computers. So that's one way. Another thing is there are many classical but quantum-inspired algorithms that we discover. So for example, you think about that, you have some kind of a good quantum algorithm for something. Usually it's not always clear whether you can somehow dequantize this algorithm, whether you can actually come up with a classical construction. So it turns out that we have few recent examples where algorithms that were thought to be good quantum algorithms, giving us some advantage in, say, machine learning, for example, can be, you know, you look at this quantum construction and then you start thinking about it and you may come up with interesting solutions that you can implement on classical computers. So, you know, the answer to, so in short, I truly believe that the future is quantum, no doubt about it, partially because I don't believe in this dichotomy between classical and quantum. But even, you know, in the sort of time scale, which is very close, say within the next 5 years, we have to do something about classical crypto systems, because you cannot just sit and wait for, because that may be too late. So there are many things that indirectly the progress in quantum technology is actually forcing the industry to go into, especially the most conspicuous example, of course, would be security and a crypto industry, but you know, there may be others. So
let me go out, as I promised to do. Questions that anybody may have? Yes, please. And just for simplicity, if you don't mind giving it a shout, and I can repeat if necessary.
What are the 3 most mature use cases for quantum, this research that you guys do? The 3 most mature applications today?
So, security.
Yeah, so I would say 3 most, or at least 1 or 2, I guess. The first, quantum key distribution or quantum security. So essentially, this is a method of transferring information based on, you know, encoded in quantum properties of individual photons, for example. It's individual particles of light that are transmitted to Alice and Bob, or two nodes. And using those keys or encryption keys, they can use to encrypt their classical communication. And, you know, key delivered in this way are tamper-proof, because if somebody tries to read the keys, an eavesdropper, it will be revealed by, you know, the properties of quantum mechanics. And using this type of encryption method, we call it a symmetric key encryption. This would have forward security, so no progress in, you know, classical computing or quantum computing would be able to break such encryption schemes. So that's one kind of topmost applications or use case. I don't know, from the I think if I may, kind of on the quantum sensor perspective, I think they're now pushing the boundaries here on sensing very accurately minute changes in gravity and so on and so forth. And the third one, I guess, I don't know, quantum computing?
Is there an obvious use case that you think is worth, just pick one?
I think laser is the most, you know, mature use case, right? Laser, that's quantum too, right? but I think you don't mean this, right? You want some other stuff. So actually, I don't know much about this, because I think still all in you know, in, how to say, in growing. So like, for example, the simulation, right? I mean, quantum simulation, that's most, I think maybe the most promising application of this quantum computing stuff. But still, I mean, we can only simulate a very small system. But I'm sure that this will definitely be something very, very, you know, people will very care about this. And another thing about it is machine learning. I mean, because we have several, you know, algorithms, which is really demonstrate some, you know, speed up over the best known algorithm. Even, of course, the speed up, when we talk about speed up, you need to be careful, but these algorithms are definitely will be, you know, very promising application too. So, but of course, they are not mature because there are many, many theoretical and engineering problems to solve. So, yeah.
Well, I should just say that we should also involve some of the colleagues from the audience, who at least I can see 3 of them here, Joel and Dimitris and Alex, who's hiding over there, and they probably have their own views and perspectives. So it would be probably good if they could, you know, this question shouldn't be only addressed to us.
Joe, as a founder, you know part of the burden of being a founder is you have to be ready to go in like 10 seconds and explain what you're doing. Do you want to give the 10-second version of Horizon?
Sure. Okay, so basically what we're trying to do is to build tools that make it easier for people to develop quantum algorithms. I think in terms of this question, when asked about what the most mature applications are, the most mature application of quantum algorithms I can see is cryptanalysis. That's currently something that's important now, not because we have quantum computers to break codes, but because we have to start worrying about post-quantum crypto now. So people need to start doing algorithmic analysis of the resource costs for breaking codes now, so that we know that the candidates in the NIST competition, for example, so that we know which ones are likely to be stronger.
Dimitri, did you want to?
Thanks for having the chance to share my thoughts as well. We in my group in security work on quantum simulation, as Ronyao mentioned, and quantum computing as well. And we already see certain cases, certain use cases, interface between hybrid quantum classical approaches, in this kind of approximate quantum algorithms, which are not very qubit heavy and can solve some real world problems, from data science and recommendation problems. And we actually, next to me is one of our collaborators from the industry world, Kantar group, and we're working together to specific use cases. And I think one of the early applications will be in this hybrid quantum classical variational approximate with near-term devices, with hardware that we're building the next few years. This is a problem that you cannot always prove you have a quantum advantage or quantum supremacy, but you have all the indication that it works, and until you try it, like in AI or machine learning, sometimes it works, sometimes it doesn't. You have to try it and see it. So I find that very exciting.
So I tend to think and articulate things in terms of examples. So when I hear the word hybrid, I think of my old industry, which was data storage. So you think of lower speed but dense SATA drive, and you think of flash memory, and you'd say, depending on the use case and the data calls, I need different types of storage. So depending on what you need to process. But interesting, because words like quantum supremacy invoke the same emotional response as singularity. And when you hear this idea of quantum supremacy, the idea is, gosh, that's when everybody becomes irrelevant. And now some of the questions, and I'm going to come to you on this one, Arthur, some of the questions involve the intersection of artificial intelligence and quantum technologies. Do we think of something which already makes us naturally uncertain, which is, what does artificial intelligence mean, and how do I relate to the future of automation and AI? Does quantum make a material and meaningful difference, as in if we were afraid of it before, we're terrified of it now because it's even faster and stronger? How do you think of this intersection?
No, but that's just human dynamics mostly. People are concerned about all kinds of things. Especially what is new is always both fascinating and a little bit scary. And people are concerned about artificial intelligence, people are concerned about quantum technologies, I hear. Now combine the two, you can have a quantum artificial intelligence, you know, that's super scary, right? But it can happen actually. So I'm sure that if investment in artificial intelligence, it would be only natural to use quantum technology for further, you know, at some point, and I'm sure that will happen. But as with everything else, you know, there's nothing to be scary about. You know, we are kind of in a situations like those guys about 200 years ago, where electricity was taking over from steam engines, right? So imagine trying to explain the power of electricity to someone who sort of lived in the steam engine kind of world. It doesn't make sense, right? So how can you explain electricity in terms of steam and piston and all this kind of pressure and vapor? You cannot. So we are facing basically this very similar situation at the moment. We're just going to this quantum domain and we try to somehow explain, and we are also at this stage where we see a real potential in the whole thing. But what will happen eventually? You know, Steve, I'm pretty sure that, like, you know, 10 years after, someone will just look at, are you filming this? You are, right? So, you know, 10 years later, someone will look at this debate and laugh because, you know, those guys were talking about artificial and this, but in fact, something else, much more fascinating, much more interesting happened. So it's like, I always try, when I'm asked by media about what will happen with this quantum technology, I like to say this: look, think that you go and interview not me but Charles Babbage about this, you know, analytical engine, and you ask the guy this question: what is it good for? And you know what he would say? Probably it's good for, you know, tabulating mathematical tables because there are so many errors in them. So you really want to have a good algorithmic way of doing this. Would he ever consider, you know, internet, word processors, Facebook, all those kind of things? Absolutely not. It's just beyond your imagination. So you have to go step by step. And I think we are this generation that is offering quantum tools to people out there. And I think it will be the next generation that will take those tools, will understand them better and do something interesting. And it's beyond our imagination. So you know, we can speculate, you know, I can just throw a few intelligence ideas, you know, and just here and there. But I'm pretty sure, you know, that 10 years from now, people will be laughing at it.
Okay, so you heard the forecast. And Babbage needed Lovelace. And so the question then is, how do we work together?
We have wonderful women working, you know, at CQT, so there's just...
All right. Yes, you had a question, please. Yes. Oh, I guess we do have a mic, sorry.
We talk about the very limited use case for now, and I agree with what Runyao said about, you know, raising awareness and education on the fundamentals of this quantum computing. I'm a complete layman, so can we back to like one-on-one basics, just explain to us that maybe just define quantum computing, and if you have one common use case in the defense area, like maybe tell us how can this be effectively used in the defense area. Say, you know, if I want to send an encrypted code, what device I would need to use, and how what's the mechanism in such that the ordinary computing cannot encrypt this thing. You know, just happy to
We got it. I mean, the way that QKD works is the collapse, and it.
Right, so in a very simple manner, so with this kind of why it's useful is also the threat context, right? A lot of cases where communication are, you know, open, you assume that it's being eavesdropped or wiretapped by someone else, is stored somewhere else. So the strength of an encryption is important because it's lying in, you know, someone else's that you don't know they have your data, even though it's encrypted. So the threat now is that the whole crypto system, this encryption method that we are using currently, will be vulnerable. Right, so then your data is stored in someone else's place. They can potentially decrypt it 5, 10, 15 years later. It doesn't matter when. But if your data needs to be secure for long term, like 25 years, 50 years, which some of the information are, government, defense, or whatever sensitive information, those were already vulnerable. And what QKD does, or quantum key distribution, is very simply delivering the keys in a very secure manner where you can trust the method of delivery. And once you know, if you implement it correctly and keys reach A and B, I mean the two nodes, and they have those keys to do the encryption, they know for sure that the keys are secure, and the method that they use to encrypt would also be safe against any potential quantum computing attacks in the future.
And so the sort of the Schrodinger's cat scenario of once observed, there's a change, and you can observe that there has been a change. You don't know what it could have been or would have been. This idea of something is both alive and dead at the same time, the classic Schrodinger's cat scenario, and once observed, that is already disturbed. So I think this interesting scenario of when you talk about quantum mechanics, and when you have observed something, you have altered it. And that's how you know something has been disturbed. So there's a lot of interesting, I think, scenario. Instead of us going through more now, part of what we seek to do with our friends at CQT is to have more opportunities for events and awareness. For example, Dimitri was with us a couple of months ago, together with Google Brain and others, going through some very interesting opportunities in education and use cases. What I'm going to do, yes, please, and then I've got another question that I'm burning to ask. Yes, please.
I've got a question around the bottlenecks. So if you look at the AIs, you take a stack, you've got data. So if you took AI as an analogy for quantum computing, the bottlenecks, sometimes people talk about the data, some people talk about the algorithms, some people talk about the software, some people talk about the hardware, or software meaning the software that talk to the hardware, like GPU versus CUDA, etc. So if you look at quantum computing today in the quantum economy, what are the bottlenecks? If you take the use case on this one, are they, for example, quantum repeater, or are they talking about the quantum computer, or are they talking about other issues?
Well, the quantum technology is a sort of a generic term, so that assumes that you have quantum phenomena to play with, and you want to understand, domesticate, and use them for something useful. Now, the main problem is to have those quantum phenomena conspicuous enough. So that means the reason why you don't see quantum effects so often is it because they are very fragile. Everything interacts with everything, and if you have your quantum device, it also wants to interact with the environment. And that basically destroys quantum property you are looking for. So the short answer to your question is the major problem is noise, noise, noise. So we want to, but that's not an unsolvable problem. We know how to handle it. There is a whole area of quantum error correction. There's the whole area of quantum fault-tolerant computation. So we want to, at least in the context of more sophisticated applications like quantum computer. So this is actually a major bottleneck. Trying to, on one hand, you want to have a technological progress. Ideally, you would like to go from valve technology into a quantum transistor equivalent. So you would like to come up with something that a technology that you can really control, that interacts with what you want it to interact and not anything else. We don't have it because anything that interacts, interacts with also what you don't want to interact. So anyway, finding progress in technology to be able to see quantum phenomena and control them better, that's one thing. Then progress in ideas how to protect quantum phenomena we are after, quantum interference, quantum entanglement, in sort of like quantum error correction. That's very important. So I think that's the major issue for us. Now, when you talk about quantum communication, no, we don't quite yet have quantum repeaters as such, but in quantum communication, perhaps those issues can be somehow dealt in some other ways. For example, what Alex and Chongyang were doing here, they were trying to, Alex and his group at CQT was interested in distributing quantum entanglement from satellites. And so the idea being that, if you send particles that are I use technical word entanglement. It means especially correlated particles into two places on Earth, and you can actually establish secure communication. In this case, of course, noise also plays a role because it's a question of the optics and detection and so on and so forth. But at least it's not as severe as it is in case of complex systems like quantum computers.
Yeah, maybe I can add a little bit to Arthur's answer. Actually, we know that noise is a major, problem for for us to difficult to build these quantum devices. But there is another more realistic issue, the money. Because, the problem is if you spend a lot of money to build some devices, of course, not large scale, right? I mean, maybe 100 qubits, for example. And then the question is how we can use this to make money, for example, or how we can make this useful. So you actually need, very useful cases to show again. So now it comes to how you can develop some very good algorithm or applications over this kind of devices to actually to make sure your devices is worthwhile the money costed. So now you can see that it's a very paradox situation, because so this is why now people are also working very hard on how we can develop algorithm. These some noisy intermediate quantum devices. So some term we use like NISQ, right? I mean, so I think this is also very important.
Well, all I can say, if you are unscrupulous, you can make money on quantum. There are those guys writing books about quantum healing, and they sell them quite well. But that's not what we want to do, of course.
Hey, Arthur, one of the questions that we had from a panel a few weeks ago when we were talking about the future of work and where roles may be going, one of the observations from a panelist was there could be a role in the future called entanglement engineer that is helping build qubits. How do you think about the type of skills? Let me just into this sort of broader question. How do we continue to build companies? Because companies require lots of different skills that include not just the scientist, but also engineers and many others. What type of roles, I mean, is an entanglement engineer somebody, for example, that's a role?
Well, sure. We want to have quantum mechanics. Those guys who have sort of more practical approach. And I think we are moving to the stage where certain technologies are understood in the lab well enough so that you can take them and you can really play with them. And to this end, at CQT, we try to organize workshops where we bring people from companies so that they can actually have hands-on experience in the lab. One way to has some interest from the industry is, of course, to communicate what it is about. And the best way is not really to pontificate and give another PowerPoint presentation, but to bring the guys who really want to play with quantum phenomena, bring them to the lab, show them that actually, many of those things is something that you can actually take from the lab and play with it. So this is coming for sure.
Another question from anybody in the group? All right, let me ask a question, whoever feels compelled to answer. There's a few moments where there's a technology that emerges and it becomes more well understood by people. So let me use some crazy examples for the moment. Noel Bushnell and Pong was sort of the beginning of gaming, home gaming, and he had a hard time trying to persuade anybody to buy this home device. People said, why would I ever do gaming at home? Then you have something like DeepMind more recently, when people started to become a bit more understanding because they'd say, oh, AlphaGo, I at least understand the concept that this AI was able to beat Lee Sedol. Is there something that we should be thinking about that becomes that moment of, I better understand now from a quantum technology perspective that brings it somehow into contact with the layman? Nobody may understand a GAN and what DeepMind builds, but they generally understand that this thing beat a human player in a game. How should we think about that moment of awareness for quantum?
Well, you mean like there's this one particular very particular application of a moment where public at large out of a sudden realizes that that's it, you know, there's something there. That's not only a bunch of geeks pursuing some kind of goals. Difficult to say, you know, it's just, we have, you know, at CQT we had sometimes very weird requests. So for example, we work on quantum random number generators, and randomness is important and so on and so forth, and people use it for, among many other things. There are people who would like to have random number generations in casino, right? So you would have quantum random number generators, and the casino authorities, you know, regulatory authorities, you know, come to us, say, okay, when those guys have those cool quantum gambling machines where there is, and you know, this is sort of attraction. I gamble with a quantum device, and it has this quantum random number generator in it. How do we know it's fair? You know, how do we know it does what it does? So, and here comes our expertise. They come, you know, can you certify a quantum random number generator for us or something? So whether this would be, you know, the crucial thing, I don't know. So would it be some applications in security? It could be, even though probably not as conspicuous as example as you mentioned.
It's interesting though, right? I mean, the reason I share that is that if you take a look, there's always these moments, and I think you touched on them, where social adoption is the issue, right? When the elevator was first around, it was something where there was a person inside that would sort of mechanically engage and disengage, and you would move up and down. And when it went to automated and without a person, people were very afraid. Just like today, you've got technologies, autonomous vehicle, and so on. So sometimes there's a moment in which something, and in this particular case, DeepMind became sort of a way of people relating to this idea of AI. It doesn't mean they understand, but the use of it to create an ability for a game to learn at a rate and to exceed that of the, quote, human player, and then for the human player to say, I became better, right? Lee Sedol came out and said, I lost to AlphaGo, but I became a better player because it did things that I didn't understand and it made me think in a new way. I'm just wondering, so I'm not asking so much for a specific answer, but just wondering where that moment of awareness, if this idea of awareness is part of what we seek to create. There's sometimes where people say, I don't really understand it, but at least I can relate to that, right? So it's interesting for us to think about. Anything that you wanted to ask before I try and give us time for getting to know each other as well? Oh, please.
Actually, I think normally such a moment comes when you actually understand something. So you say, wow, it works like this. So for example, who will be the strongest supporter of this quantum computing or quantum mechanics? If you can really understand what is superposition, maybe entanglement, or this kind of thing, and then you're convinced, maybe, right, then you actually will be definitely will support for this. So I think for this AlphaGo is a good example. But why I see the understand something really important, because nowadays, you know, these large companies all build very huge, you know, like a platform. So people actually, you don't have to build stuff from the zero. So you have all, like you just mentioned DeepMind, but like Baidu is also doing AI, and we have Baidu Brain, we have Paddle for this deep learning, you know, so all this framework. So that means all you need to do is you really understand the concept. And then you can actually use all this to do the creative work. So I think for me, I think the wow moment, or the most important moment, comes from you actually understand the fundamental concepts of this. This comes again to the education issue. I think that's maybe people really need to deeply learn, you know, this kind of stuff. Okay.
One very quick comment, more on the kind of education side. I think we have people in the audience that, one-on-one in quantum, they want to learn what one-on-one in quantum, which is absolutely relevant, right? I think just through, science, quantum science has been along for a long time, for past 200 years or so, and there's a lot of progress. But not everybody knows about entanglement, superposition, which essentially is in every one of us, right? So I think this transition and, hype, companies building quantum computers, security, and so on and so forth. And if it manages to reach the mass and make them curious about what this entanglement is and what is in each and every one of us, and also in a wider universe, and make, to Runia's point, just learn about that wow moment about entanglement, how it actually works. I think we probably have done a lot to kind of reach out to the general public and just make them excited as we all are about this field in quantum.
Was there one other question? Yes, please.
Yeah, Steve, you started by mentioning about capital and investments. So one of the questions which I have
Go ahead. But yeah, I think the idea is, okay, if we're patient, I'll paraphrase, but if we're patient as investors, are we ultimately chasing something that is worth it, right? So yeah, don't mind waiting. We'll go up and down, let's keep going, but eventually it'll be worth it. You'll forgive the comparison because I'm sure everybody will boo and hiss. But if you say, there's a lot of people that are Bitcoin bulls, right? And they'll say, may take 6 months, may take 6 years, but for sure Bitcoin will reach, 50K. Right, so it doesn't matter whether it's 3,000 today or 9,000 today, because it's only going to end up being 50,000 at some point, just a question of when. Is there a way for us to be so optimistic and bullish? Now, if we listen to Arthur, the answer is, well, everything's quantum, so the answer is yes, of course it'll be important. But, the question is it worth it? And I want to push on this for a moment from an investor's perspective, because the transition from academia and research is important, and although people need to be patient, it's just an opportunity cost. If I have $1 million and I can put it into an e-commerce platform or quantum technology and I can see a 10x in 4 years versus, I don't know X over I don't know years, that becomes difficult.
Yeah, well, first of all, I'm not a big investor, and I can, as a scientist, there's a very interesting cultural divide, between scientists and people on the commercial side. I even know those end users, like military people. In the earlier days of quantum computing, quite often, it was mostly not so much from maybe commercial sector, but from military sector. You always had this question: when will you have this device? Like the quantum computer was referred as device, like atomic bomb, right? All the habits die hard. So when and so on and so forth, and then there was, in the background was, shall we put lots of money into this, and what are the chances that it will have? And scientists actually look at it from a completely different perspective. Actually, scientists really wanted the whole program to fail for a good reason. So namely, if there is a good reason for which you cannot build a quantum computer, this is much more interesting from scientific point of view. Because you discover something that is truly important about nature, right? You discover something that may allow you to, you discover a new phenomenon, and that may allow you to utilize this phenomenon perhaps in a different way. But for a real scientist, the most interesting scenario is not to build a quantum computer because there's a fundamental reason we cannot build a quantum computer. Whether people on the sort of, on the commercial side don't look at it from this point of view. It's not, this is on one side you have a curiosity-driven approach. On the other side, as an investor, you're asking me, okay, the typical narrative from the commercial sector. Okay, I'm looking for a 5-year horizon because it makes sense. What will happen? Can you have a product of some sort that I can sell within 5 years? And then as a scientist, I have just no idea whatsoever, I will probably be surprised that you will have a product. It will not be quantum computer, to be sure. This I can assure you. In 5 years, I don't think that you will have a quantum computer that will be making money for you. But you will have security systems that are based on quantum physics. So if you want to invest, probably look into sort of a crypto sector at the moment. Or high precision metrology. New generation of atomic clocks have to implement quantum entanglement. And this will affect the future of GPS. If you're looking at very precise gravitometers, and that would, there are cases, military scenario, submarines and so on, where you cannot really use GPS as we use it today, and you still want to navigate. So you have to have another very good sensors that will tell you where you are on the basis on sort of accelerations and positions, and so on and so forth. We can solve this problem too. And so I think as we are able to control more and more quantum systems, there will be applications. But, I certainly, if I were to give you advice, don't put all your savings on a quantum computer at this point, okay? But you may be quite okay putting a little bit in some areas of quantum technology.
So there's a company called Atomionics that's working on some of these positioning technologies as well. But I think the important point is it depends on your perspective, whether you want to, using the sports analogy, go to where the ball is likely to be. And so if we're generally believers that these technologies will continue to mature and emerge in new ways, we want to be a part of it. From an SGInnovate perspective, that's the whole reason we exist, is to try as best we can to be more patient capital. But it is true that these things are still a challenge. But if we think more broadly, that's why we're here. That's part of the whole discussion and debate, is to explore and find those opportunities where we can to build awareness and momentum, right? So last question, and then we're going to go to some time to have with each other. Dimitri, are you speaking or asking a question or answering or? Okay, here you go, right here you go.
Just a follow-up on this. Nobody knows. Nobody knows how to make a quantum transistor in the same way we did in the 50s that would work. But at the same time, you can never predict what to do with it later. I mean, there's so much interesting things coming by engaging the two communities, the commercial community and look at the software industry at the moment. I mean, there are 2 or 3 hardware providers, but there's a lot of, everything we know about computing is about, Facebook or Google, and so it's software-based. To build software, to think about algorithms, you have to, especially quantum, is all very, very exotic. So we have to start from awareness training, and then, when we engage with I see that in my research the last couple of years, by talking to companies, I just find completely new ways of thinking about quantum, algorithms and quantum theory, much more closer to reality. And can you imagine by putting, some sort of quantum simulator or quantum computer on the cloud and allowing all these whiz kids to go in and play with it, what would come out? Nobody knows. It's like amazing things. So I think there is a lot of things happening and very difficult to predict.
So just taking this idea of different use cases, NVIDIA, everybody thinks of graphic process, and then you think of gaming, and then suddenly NVIDIA said, gosh, these GPUs are pretty cool in terms of new AI application, but didn't know at the time. But quickly on this one point, Arthur, I was reminded of a time that I met one of the Nobel Prize winners for graphene. And I was so excited to talk about the different use cases because I'd done some research previously on how much Samsung and how much all these. And he basically cut me off in the middle of the sentence and said, I couldn't care less, right? I was only interested in the science, right? Who uses it, how they make money from it, I have zero interest. And with that, he walked away. So I am reminded of the difference of these, sometimes these two cultures finding each other. But that's our goal for this type of discussion, is we each bring something to the table and we just need to learn a little bit more about each other. But our goal is to help amazing scientists at CQT see how they can bring what they're working on out. We'll learn along the way, but if all of you are interested in being a part of that journey, that would be amazing also. And so I do want to leave time for the networking, so what I'll do is just say thanks to Chunyang and to Renyao and to Arthur, and thank you to you.